Out in the dry savanna of North Queensland sits the old mining town of Charters Towers. At first glance it looks like just another quiet Australian country town. Dusty streets, scattered gum trees, and a skyline dotted with old mine headframes. But beneath that ordinary landscape lies one of the most extraordinary concentrations of gold ever discovered on the continent. Over a period of just a few decades, miners pulled more than 6.6 million ounces of gold from the ground here. At today's gold price of 7,333 Australian dollars per ounce, that works out to roughly $48.4 billion worth of gold in modern value. And the most astonishing part isn't just how much gold came out of the ground, it's the grade of that gold. The ore mined at Charters Towers averaged about 34 grams of gold per tonne of rock. For context, most modern gold mines operate profitably on grades between 1 and 3 grams per tonne. Charters Towers wasn't just rich, it was wildly rich. And yet the goldfield began in a way that was almost completely backwards compared with most of Australia's famous gold rushes. When the Great Victorian Rushes started in places like Ballarat and Bendigo, miners first found gold in creek gravels. Those deposits are called alluvial deposits, which simply means gold that is eroded out of rocks and being concentrated in river sediments. At Charters Towers, something unusual happened. There was almost no alluvial gold. Instead, the goldfield was discovered directly in the hard rock reefs, quartz veins running through the bedrock itself. In fact, according to the story passed down through the early mining camps, the discovery happened in 1871 when a prospector's horse named Saturn dislodged a rock that glittered with visible gold. The prospectors examined the area and quickly realised that the gold wasn't coming from creeks or river gravels. It was coming straight out of quartz veins cutting through the bedrock. That meant the field began as a hard rock mining rush, which was extremely unusual for Australia at the time. To understand why Charters Towers was so rich, you have to go back hundreds of millions of years, long before Queensland existed as we know it today. The goldfield sits within a region geologists call the Ravenswood Batholith, a massive complex of granitic rocks that form deep within the crust. A batholith is essentially an enormous body of magma that cooled underground, forming granite and related rocks. These rocks were in place between about 480 and 410 million years ago during the tectonic development of Eastern Australia. But the gold itself didn't form when the granite first cooled. Instead, the gold arrived later, carried by hot hydrothermal fluids that moved through fractures in the crust. These fluids formed during a major tectonic episode within the ancient Tasman orogeny. An orogeny is simply a mountain building event caused by tectonic plate collisions and crustal deformation. During this time, the crust in northeastern Australia was being compressed and fractured. Those fractures allowed deep fluids, heated by the Earth's interior, to rise toward the surface. Geologists classify the Charters Towers system as an orogenic gold deposit. For non-geologists, that simply means gold formed during mountain building events when fluids moved through fractures and faults deep underground. Those fluids carried dissolved gold, sulfur, and other metals. Eventually, they encountered zones of brittle fracturing in the granite, essentially networks of cracks where the rock had broken under stress. These fractures formed quartz veins, which miners later called reefs. A quartz vein is exactly what it sounds like, a sheet or vein of quartz mineral that fills a crack in the rock. As hydrothermal fluids flowed through these cracks, pressure dropped and the chemistry of the fluid changed. When that happened, the gold could no longer remain dissolved. It began to crystallize out of the fluid. The result was a network of auriferous quartz sulfide veins cutting through the granite. Auriferous simply means gold-bearing. Many of these veins formed along major crustal structures, including the Charters Towers Ravenswood lineament, a deep structural boundary that acted like a plumbing system for mineralizing fluids. In simple terms, the crust cracked open and allowed hot fluids from deep underground to surge upward. Where those fluids stalled or mixed with cooler water, the gold dropped out. But the structural plumbing alone doesn't explain why the grades were so spectacular. The real secret of Charters Towers lies in the way the gold was concentrated into ore chutes. An ore chute is a portion of a vein where gold becomes highly concentrated over a relatively short distance. These chutes often form where structures bend, split, or intersect. Imagine a fracture in the rock that suddenly changes direction. That bend slows down fluid flow, creating a kind of bottleneck. When that happens, minerals can precipitate rapidly, forming extremely rich pockets of ore. At Charters Towers, many of the famous mines, including the Brilliant and Day Dawn reefs, exploited exactly these kinds of structural traps. 2 reefs alone produced staggering amounts of gold. The Brilliant Reef yielded roughly 2.1 million ounces of gold, while the Day Dawn Mexican system produced around 1.6 million ounces. These deposits were narrow, sometimes only a metre or two wide, but incredibly rich. In some places, the quartz veins carried ounces of gold per tonne, which is almost unheard of today. Another interesting question is whether the gold at Charters Towers was free milling or refractory. Free milling gold means the gold occurs as visible metallic grains that can be easily liberated by crushing and gravity separation. Refractory gold, by contrast, is locked inside sulfide minerals such as arsenopyrite or pyrite and requires chemical treatment to recover. At Charters Towers, they were blessed. Most of the gold was free milling. Miners often found visible gold in the quartz veins, and much of the ore could be processed using relatively simple crushing and stamping mills. This was one of the reasons the field became so productive so quickly. That said, the veins also contained sulfide minerals such as pyrite, arsenopyrite, sphalerite and galena. These minerals sometimes hosted additional gold that required roasting or chemical treatment to extract, particularly in the deeper parts of the system. But compared with many modern deposits, a large proportion of the gold at Charters Towers could be recovered using relatively simple 19th century technology. That technological advantage mattered enormously, because the ore was both high grade and relatively easy to process. Mining companies could extract large quantities of gold even from narrow veins. Within a few decades, Charters Towers had transformed from a remote outback outpost into one of the richest mining towns in the world. At its peak, the town had a population of around 30,000 people, making it one of the largest cities in Queensland at the time. Hundreds of mines operated across the Goldfield, and shafts descended to remarkable depths. Some mines followed the reefs to depths approaching 1,000 metres, which was an extraordinary achievement for 19th century mining. Steam engines powered winding systems, pumps removed groundwater from the shafts, and crushing batteries processed the ore day and night. For a period in the late 19th century, Charters Towers earned a nickname the world's richest goldfield. Yet despite that staggering production, the district remains geologically fascinating for another reason. It challenges the assumption that Australia's great goldfields always began with alluvial discoveries. At Ballarat and Bendigo, gold eroded from quartz veins and accumulated in creek gravels, leading to massive surface rushes. At Charters Towers, erosion had not yet exposed significant alluvial deposits. Instead, the gold remained locked within the hard rock veins themselves. That meant the discovery was effectively a reef gold rush from day one. Prospectors weren't panning creeks, they were chasing quartz veins. Even today, the geology of Charters Towers suggests that the story may not be finished. Large portions of the Ravenswood batholith remain poorly explored, particularly in areas covered by younger sediments and deep weathering profiles. Modern geophysical surveys indicate that many of the structural corridors that hosted the historic reefs continue beneath that cover. In other words, the plumbing system that created the goldfield may extend far beyond the areas mined in the 19th century. If new deposits exist, they may lie deeper underground or hidden beneath layers of soil and sediment that the original prospectors could never see. And that possibility adds one final twist to the story, because despite producing billions of dollars worth of gold, Charters Towers may still be holding on to some of its secrets. Beneath the quiet streets and old mine headframes, the same fractures that once carried gold-bearing fluids through the crust are still there, frozen in stone, waiting for someone to follow them again. I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.